Okay, now let me show my code here. This week I created a new class binary tree, inheriting from the versatile digraph. I created the constructor for this binary tree, which contains two arguments, node ID and node value, because I hope that the user inputs the node ID and node value when call this class to define the root node. And I add this constructor. I call the init function of the superclass, which is a versatile graph, because I want to use this data structure and the method of the superclass, which is list nodes and dictionary nodes values. I want to use these two data structures to store in the parent class to store the nodes and their values. And here I call the add node, which is a method from the superclass to add this node ID and node value, which is the root node to this list nodes. And because I didn't have a data structure to define the relationship between the parent node or the child node in the binary tree. So here I create a new dictionary of binary tree. And in this binary tree, firstly, I defined this node ID, which is the root node, and it has a sub dictionary. In this sub dictionary, the value for the key of left is none because I has now I has now defined its left node, and its right is also none because I has not defined its right node. When I use the method later, I will set the none for the left and the right to its left node and the right node. Okay, and I define a new method, add node left, to add a new left child node to the specific existing node. That is the parent node. Using this method, and firstly, I call the get node, which is also a method from the superclass, to see whether the parent node uh, is in this list, whether there is this node in the graph. If not, I will raise the assertion error with a message of the parent node does not exist. Also, I also check whether this parent node has already had the left child node. If so, I will raise the value error. The left node of this node already exists. If the input value is valid, I will call the add node, which is the method of from superclass, to add the child ID, a child node, and the value of child node to this list nodes. And then I will also, because here the root node has not root, the parent node had has its left node, so I will update this dictionary to set the left node of the parent node uh, using this dictionary, using this inner dictionary. So here, uh, the the value for the key left, for the left of key is I'm sorry. Here, the value for the key of left on this parent node is this child node. And at the same time, because I have a new child node, so I add this key to the dictionary, and I also create a sub dictionary for this child node. Here it's doesn't have the left child node and the right child node. So I set their values for to none. And I did the same thing for the add node right. The only difference is it just check the parent node, just check parent node and check whether the parent node has already had a run node. And I set this child node to the value for the uh, right of the key to the parent node. And then I also add a sub dictionary to this child node ID. And then I define two methods to get node left and get node right, which means I want to return the ID of left child node or right child node for a given node ID. First, I also uh, handle exceptions. Mm, if the node ID are not in the dictionary, that represents the relationship, I will raise a key error. The parent node does not exist, and if the parent node exists but it has neither neither left node or nor right node, its return value is none. It's not an error, but it will return none. So I will use a warning to indicate that the result is none. And otherwise, I will return its left node. And the same thing for the get node right. I will check uh, whether the input value is valid, and I will show their warnings if its right node is none. Otherwise, I will return its right node in this dictionary. And the last method is the plot. I will plot a binary tree using the nodes and their relationship. Because the binary tree here is not a directed graph, it's undirected graph. So instead, I use the object graph in this graph feeds. And I just add nodes and edges to binary tree. So here I use the for loop statements to iterate array nodes and edges within this dictionary. Here, if the node has neither left node nor right node, I will skip this session uh, for add edges. For example, this 31, if it because it doesn't have left node and right node, so I don't need to set edges for this one. And if the node only lacks the left node, I will create a dummy node to occupy the space and adjust the structure of the graph. I will show the function of this step later because if I don't do that, I didn't do this, the binary tree, the graph of binary tree will become different. Also, I will add two dummy node uh, in the middle to occupy the space. Here, I add two dummy nodes and set its style as invisible, so I can't see it. It just used to just used to the occupy of space. Also, if the node doesn't have the right node, I also create a dummy node to occupy the space. Okay, let me show the the method of this binary tree class. Uh, in this code cell, first I will create a binary tree with a root node of a with a node value of 8, like this, and then I add other nodes to the binary tree like this. And after that, I will plot the binary tree like this. I think it's the same as this picture. Yes, and if I don't have if I don't have this steps, let me comment it. I don't have this uh, see. Although it's still a binary tree, but its relationship is not very straightforward. In this picture, it has left node and the right node. The left node is left down to the parent node, and the right node is right down to the parent node. But in this picture, it has some vertical edges. It's not the left down and right down. It's vertical. So I indeed create some invisible nodes here, in between, in the middle of two nodes, in order to occupy the space, so that the left node will be left down to the parent node, and the right node will be right down to the parent node. Okay, so and let me check the get node left and get node right method. Let me see. I want to see the left tail node of C is. I think this is C. Yes, this is C. When I hover up my mouse onto this node, it will show the node ID of this node. And C and the left node of C, this is F. Yes, I can see the output is F. And for D, I think this is D. Yes, this is D. And the right node of this one is I. Output is I. Okay, and that's what I did in this week's assignment.